Hey everyone, welcome to another Common Lisp study group. I'm your host, Ron Baden with Atlanta Functional Programming. Today we're going to be discussing the UIOP library, a library that's part of the ASDF distribution, but something that we did not actually get a chance to cover in past episodes. Kind of really skimmed this library. My motivation in talking about this library in particular today is due to some stuff that I've been doing where I ended up using some older libraries for just simply interacting with the shell environment that turns out have been subsumed since the last time I used them to be part of the UIOP distribution. In fact, they added a couple of additional features. Through reading the README at least on UIOP, it turns out that UIOP actually subsumed quite a few libraries that I used to use in the past, which kind of motivated me to realize that it might be a useful thing to actually go through with what UIOP actually provides as part of ASDF 3 in an effort to sort of consolidate people's knowledge from other libraries and maybe even add some of those features or those functions in those other libraries that they commonly use for interacting with the shell and the operating system in a portable fashion, because that's one of UIOP's goals. It is going to be a set of utilities. As the name stands for, it's a set of utilities for implementation OS portability. So that's what we're going to be covering today. UIOP is actually a fairly large library, much larger than what I thought it was. It actually consists of several sub-libraries, and we'll be covering only a few of those today, just because there's a lot of them. There's about maybe 7 or 8 of libraries as part of the UIOP distribution. At the end of this presentation, I will post in the YouTube description the UIOP GitLab documentation. UIOP is actually not on GitHub. It's actually been moved to GitLab as part of the ASDF move to GitLab. So I will post a new repo URL, especially because I actually had the old GitHub URL bookmarked, and it turned out that was no longer even used anymore. Anywho, so let's begin. What is UIOP? As I mentioned, UIOP it stands for the Utilities for Implementation OS Portability. Its goal was to provide a portability layer and be the basic utility library layer as part of ASDF 3. In it includes several things, and I'll just briefly mention, some of the major libraries that it provides. But it includes many sub packages. You could think of Lisp packages for interacting with the operating system, the file system in a portable manner, because as most of you know, although we have path name objects inside the Common Lisp standard, it's been in the Common Lisp standard for a while, relative path names, absolute path names tend to be implementation defined. There isn't anything specific in the hyperspec that alludes to dealing with certain ways of interacting with them, CL path name objects, and there was some flexibility in the hyperspec that allowed you to that allowed different distributions to kind of diverge in how they interacted with path names. So UIOP provides a path name package to interact with those different traps, and gives you a way of, in a portable fashion, to specify things like relative path names. Additionally, there are packages for dealing with the standard streams. It gives you a nice little portability API for the standard streams, dealing with the different namings across the different implementations, as well as character encodings and being able to deal with the different external formats, temporary files, those sorts of things. Like I said, there's about maybe, maybe 12 or 13, even a little bit more in terms of terms of packages that are available, and they are actually part of built-in ASDF 3. So if you have ASDF 3 installed, as far as I know, and those of you who are more experienced about this, feel free to comment about when you're setting up packages. But I don't believe you need to actually go and import these into packages, just because since you are using ASDF 3 as part of Quick Lisp, and in general it's a very tightly integrated package manager as part of most common Lisp distributions, you get this utility library for the most part for free. Now, if you're going to be using probably newer versions of this library, it might be useful to go ahead and add it as a dependency in your project. Of course, you can certainly do that by just opening up your ASDF file like I'm doing here. Since I actually just pause. You could just simply add it into your project itself. So let's kind of get started with some things that at least I was dealing with a couple of days ago. Which motivated me to actually bring this up as a topic for presentation. Like I said, there are UIOP kind of combines several libraries that were, for the most part, were all actively used in various projects and sorts. Some of which that I'm thinking of is, for example, Trivial Shell for actually interacting with the shell environment, or Trivial External Program, or CL Launch, which was used for actually launching different applications as utilities from the command line inside your Lisp application. All of these are different libraries that were utilities that made it easier for you to interact with your Linux shell. Usually, now you can certainly see. I think CL Launch also, maybe not CL Launch, but there was another one that was also a little bit more portable across different operating systems, Windows and Linux. But unfortunately, the name of the project is not in my memory. I don't remember what the name of it was specifically. But we'll get to a couple of the other things, like CLFAD, which was used for what was it? It was basically the original kind of portable path name library that Peter Seibel kind of started in his Practical Common Lisp book, but was extended with some additional portable path name objects. UIOP actually extracted that, and expanded it, improved it a little bit, and added it to the core UIOP library. So that's a bit of an overview. Let's get straight to some code. First thing that I was going to go and show today is something pretty simple. It requires us to, let's say that we want to actually be able to interact with the shell. Now, this is pretty common for most of us, who are trying to use Common Lisp as a shell scripting language. I personally have tried to use it when I through Roswell, which allows us to actually go and interact with. It gives us a little bit of a common shebang notation, so you don't have to actually learn the shebang notation of your individual Lisp implementations. You could switch between different Lisps, and it will compile and run those scripts as is in the environment of your choice. One of the nice things about having that kind of portability is that you could try and find the right Lisp implementation that'll give you the best code for your given application. But to actually interact with the shell, you're going to have to, obviously know what it means to actually go and interact with the shell. Now, I'm not going to go and start talking about, mainly doing standard in and standard out, because I think most of us have have dealt with that, at least in our Lisps of choice. I will show you what UIOP provides a little later for some of those global like stream outputs, but for the time being, I'm just going to go and do a simple, defun that will print out our home directory that we're currently in. Okay, this is pretty common for, if you're in, when you're running your Lisp implementation, you'd like to know what $home is. Okay, $home is an environment variable that's part of, every Linux distribution, actually every Nix distribution. You should be able to see it, and, for example, if we go here and fire up a shell, and we do echo $home, you can see that it's going to print out /user/Vadim here. So this is what we're kind of expecting when we go in and print out this guy over in our example. So this is going to just print home shell. So the way to do this in UIOP, and I'm just going through some of the common operations right now. You can see obviously that there is many APIs here. So, just to give you an example of getting the current directory, you could go ahead and run get cwd, and this is just going to show that we're in the present in the current directory. This is also going to be $home, which we can also get when we do get env, and you ask for home. Get env takes in a string, if I remember correctly. So we're just going to go ahead and print that out. Hold on a second. Oh, sorry. What? Oh, I forgot. Sorry, my apologies. I forgot to quick load this project. Oh. There we go. So with getenv, you're grabbing environment variables that are already inside your current shell. Now, for those of you who aren't as familiar with processes, I'm just going to give a brief overview here. But when you start up any application, regardless of and this is I'm trying to hone in on just Linux here and Nix operating systems for the moment, but it's something similar in the if you're running like SBCL or any Lisp distribution in a pure Windows environment. But when you start up an application in those environments, what happens is an instance of your environment, okay, gets copied to that application. So whatever current environment variables that are in that application, those are the environment variables that your application process has access to. Okay, so if you say use, I think if I remember correctly, there is a set. So the reason I bring this up is, and this is just a reminder for myself, is UIOP, as far as I know, gives you the ability to grab environment variables that have been currently defined, but it does not allow you to, like in C, set an environment variable to a particular function. This is important because for those of you who want to use an environment variable, but based on some sort of configuration, set it so that other aspects of the environment, the other aspects of the application will have access to that, new configuration. As far as I know, that is just not possible. Again, I'm just letting you know, as it stands, UIOP does not provide like a set env. Now, if you need something like that, they're almost always they're very open to actually getting feature requests and even hearing about how to improve their utilities. But right now, that does not currently exist. Additionally, there is some stuff that's pretty common to a lot of Lisp implementations that UIOP kind of extracts in this layer. So just to give you guys a brief thing that I'm doing right now that is slightly different. I'm showing you the exposed API at the top level through the UIOP namespace. So UIOP : will contain all of these exported symbols. But that said, these aren't, when you're looking at the documentation, they're split based on their utility. This is something that I didn't realize. I thought there was a top level package, but it actually looks like there is a sub project per package and per utility library that you're using. So for example, what we're currently interacting with is the OS library, the OS package inside UIOP. That contains everything for interacting with the shell. It's going to also contain things like being able to interact with some common utilities that are available when you're trying to talk to your operating system. Things like this. Those are in these packages. So as we go through these, and I'm mentioning a function here, look up the function and figure out which package it is in, and then you can go and look at the code, because that's kind of that's the exported API is not necessarily defining a single like Uber file that contains everything. These are all split across multiple files. So let's continue our discussion of the OS space here. Like I said, Getenv gives you the ability to get home. We have getC. GetCWD will give us the current working directory that we're currently in. Let's say that we want to change the underlying working directory. Well, for that we have chdir, and then we could specify a path. So let's say that we want to go to, just say, my documents folder or something like that. We could certainly do so, and when we run that, and we do a get CWD, you'll see that we're actually changed in our underlying documents. All this is again within the running Lisp image. So when you quit, obviously this isn't going to be. This is going to be set that way unless you dump the Lisp image at the time that you're developing. Now there is one thing that I was going to mention here, which is probably the first obvious question for folks who are still somewhat new to these to the Lisp environment, interacting with Lisp environments with the underlying operating system. A lot of these APIs, and which is again one of the motivations behind UIOP, and I'm going to be reiterating this throughout the entire presentation. There is more than likely an implementation-specific API associated with each function that you're dealing with in UIOP. Now, do I recommend you use those? I would I personally would prefer to go as portable as possible and use the lowest common denominator. This way you can cast a wider net across different Lisp implementations. Now, if there's a particular need for some implementation-specific functionality inside your application, then certainly checking out the underlying Lisp implementation APIs and their manuals would probably get you to something that would suit your needs. If you look at Clicky or CommonLisp.net, that talks about UIOP, they do mention that. And in fact, if you go and look at like Clicky, I think is the one that uses, when you talk about shell scripting, it mentions that if you really want to, no, I think this was CommonLisp.net that actually says this. If you really want to actually use your Lisp-specific APIs, you could certainly do so with the following, and they give a nice little table. One of the advantages of using though UIOP, and this is the other thing that I want to bring up, is that it supports not just the 4 that are mentioned inside the Clicky documentation for Unix shell scripting, but it also supports ABCL and Allegro and LispWorks. It's about 5 or 6 different actually, I think it's about 10 different Lisp distributions that it actually has a portability package for. And this includes some packages that don't cover, some distributions that don't cover everything in the Common Lisp hyperspec. And it papers over some of those substandard implementations by providing their own implementations for those gaps. So if you look at specifically like their Common Lisp package layer, the UIOP provides a bunch of different exported APIs for creating some gaps for creating things like broadcast streams, additional APIs for like reading and writing sequences. But those are specific to, and this is very, very important, Lisp implementations that don't necessarily have that functionality, or, and this is more important, it's a substandard functionality. So there are some Lisp distributions that haven't been maintained and are coming back into active development. Some examples of this are like, Corman Common Lisp, which is available now. It has an open source project as far as I know. GCL, Genera, MCL, those sorts of distributions which may not have newer APIs, and by newer, it's relatively speaking. Those are APIs that might be in the hyperspec, but at the time that the hyperspec was finalized, it wasn't actually actively being maintained anymore. So those of you who are using those Lisp distributions, please look at the documentation for more information. Okay, so let's go into. All right. So let's talk about what else is in the OS package. The OS package contains, like I said, a lot of different things for interacting with your shell environment. This includes things that you can normally get through by querying the shell. So if you want to know what operating system you're running on, my apologies, I have a little typo up there. You could certainly do so. You could also inquire about, what is it, the architecture, the underlying system architecture. You can inquire about your host name. There's a lot of different applications. Functions in this API. I'm just briefly covering most of the major and common ones. One particularly useful one that that's good for a check when you're writing your applications that UIOP provides. And normally you would write this in other languages, do a get env and then check to see if you actually even got something. Instead of doing that, you could actually check to see and inquire whether or not a specific environment variable exists. So if I say, test env, which doesn't exist, you know that you will get a nil. If you go and check if home actually is available, it will actually not only get it, and it will return it as well. There is one other thing that I wanted to actually show you with respect to this OS namespace. Just give me just 1 second here too. I think it's, what's it? Not this one, because of the fact that it didn't deal with Unicode. It was, OS command guy. I think this is one. If you needed to actually check to see if a particular if you need to write a particular piece of code that is OS specific, you could certainly do so by inquiring what type of OS you are actually connecting to. So the lowest common denominator here is detect OS, which will give you a nice little enumeration, keyword enumeration for it. There are some convenience ones is detect, I think Unix. Sorry, not detect. OS Unix P. You can actually go ahead and write, check to see if it's OS or Windows, or I think what's the other one? Mac OS X. One of the nice advantages of having these little convenience predicates is for those of you who have written build systems before, and for those of you who have actually had to write a lot of platform-specific code, being able to inquire about this from Common Lisp in a portable way is immensely powerful, because then you could write some common code checking different operating systems that can work across different Lisp implementations. And you don't have to actually use the underlying Lisp implementation way, because some Lisp implementations provide this functionality. In fact, I know SBCL does. I think CCL does. I don't know about some of the other. ABCL does through Java, because Java actually provides something similar to actually go and detect what the operating system is and so forth. But there might be some gaps there that you needed to write some code, some common code, and UIOP provides that. So you can now use these macros inside your applications when you're actually, sorry, not macros, these predicates inside your applications, so that you can write things in a portable fashion. So that's the OS namespace in a nutshell. Again, I didn't cover some of the things like implementation identifier, because these are all related to the underlying Lisp implementation that you're dealing with. But if you need some of those, you can certainly use it. So this might be useful for those of you who are writing applications, and you need to provide some information about the underlying Lisp upon which you've actually built your application to your end user. Any questions so far? Okay. Let's move on to something a little bit interesting. I'm just going to cover the library today for shell scripting, and then things that are commonly used for shell scripting for those of you who are like me, who try to adopt Common Lisp as a shell scripting language. This is particularly useful for those of us who tend to write dirty scripts too as well. So, so let's move on. But before I go, before I move on to the next package, there's one thing that I want to mention for those of you who might be using the OS package for looking at a particular Lisp implementation's features to see what is supported or not supported by the Lisp, because UIOP does provide a nice little predicate called feature P that does that. Feature P requires that you use, just like the underlying Lisp implementation does, the keyword argument that's defined for the given feature. So if you guys ever used the features, you'll see each of these are particular keyword arguments that are part of your Lisp. In order to use UIOP to check to see if a particular feature is available or not, you have to actually use the same keyword argument. Otherwise, it will not actually, it won't take in a string as far as I know. So if you do quick Lisp, I think this will work. Just a little heads up for those of you who need that kind of functionality right now. Okay, so let's go to before we move to file systems of path names, let's talk about Lisp just for a minute and what UIOP provides specific for writing Lisp code in a portable package. So most of you are aware of how packages are defined in Common Lisp. We've talked about how packages are defined in Common Lisp using exported symbols and some of the underlying APIs dealing with symbols that are being read in versus symbols that are being imported versus things that are considered to be internal symbols in a package versus external symbols, that is, things that are part of the external API that the package is providing. And we've reviewed, the difference between interacting and accessing an external API call, which we've been doing so far now when we used a colon. So the colon, again, has a brief review, is only showing what's available in the underlying export keyword that the package defined as. And for those of you who haven't seen this, this is normally how you would define a package that is going to be providing external APIs that will be accessible using the colon. Now, there are some limitations with the current package system uh, architecture that's associated with and some there have been some implementations that gone in and fixed some of those things, and this is things like uh, packages do not allow you to do like upgrades of their APIs. They don't have a some convenience APIs for looking up for particular symbols and so forth. UIOP provides a nice little convenient API for defining packages in a way that allow you to have some of these features. If you look at the actual package Lisp package that's available in UIOP, you'll see a couple of these. So one of them that I can demonstrate here is find package. UIOP provides a find package API. Hold on a second, let me just correct this guy here. Yeah. Find package star allows you to specify a package designator and if an optional error message if you need to provide something. This usually takes in, I think, a keyword argument, and it'll go look up in your package system in a portable fashion to see if a package is there or not. If we say decided that we wanted to export our little function that we just did here, which we now did because we recompiled the package into the Lisp image, and we want to go look that symbol up, we could certainly do so by just doing find symbol, and symbol is the name of the function that we're defining. Now, symbol could be either a variable or a function. Remember, Common Lisp is a Lisp too. You get to provide the package designator upon which you expect it to be available. And you'll see that since I didn't provide actually a symbol characteristic, a string, instead I provided a string, we'll just dump that. But if I do this, you'll see that print home directory does exist in the AFB package, and it is an external symbol. Now, if you created an internal function here, let's say simple dumb function that adds two numbers, right? And we try to use that here. You'll see that it'll be able to find it and it'll return the internal symbols. This is again multiple return values for folks who aren't used to this again and watching the stream. This is somewhat important to know the differences. Now, again, this is a portable API behind some specific APIs that you can use to do something similar inside Common Lisp. There are APIs here that can do the same thing. I think Apropos gives you some ability to actually do some of the symbol lookup too as well. But this is a clean way of actually writing it, so you don't have to necessarily worry about the underlying Lisp way of actually doing things. Some additional things that UIOP/package provides that I'm just going to briefly mention here is a bunch of predicates that are related to checking if a symbol is being shadowed or not, whether or not a particular symbol is a standard Common Lisp symbol, the the package name upon which a symbol is created. So if you want to look up, and this is a pretty particular useful function, you can use symbol package name is a keyword. Second, did I mess that up? I may have. Messed up what that was supposed to do again. 1 second. Thought I messed it up. Okay, that's right. It's defined. I think this is requiring me to do that. Type symbol. What doesn't do that? 1 second. Oh, that's right. So my mistake. So UIOP symbol package name basically checks to see where the actual symbol is defined. So here it's actually returning the whether or not the package that the current package is defined or not. If that matches what's available in a given symbol package. 1 second here. This is I wrote that down incorrectly. Gotta update my notes. Okay. Let's move on. Additionally, in addition to some of these things that that we were talking about for symbol shadowing and checking to see what package a symbol is available, there's some common portable ways of actually being able to make symbols, import symbols. These are all shadowed at higher level APIs that UIOP/package provides that you can use in place of actually using some common Lisp standard functions, as well as all Lisp implementation specific functions for interning on interning symbols, being able to actually define packages and so forth. The one thing that I want to really encourage to use is define package instead of def package. Because define package has some functionality that is available that that will help deal with like upgrades, name conflict, version differences, and so forth. So let me just pull up an example over here. It might be useful for me to actually go and define it. So if we end up using instead of, let me just go up here and say this UIOP package instead of that. If I do that, the define package itself is more or less going to do the same, use the same export symbols that you'd see before. The difference is it will ensure some additional checks before it actually goes in and exports the underlying package into the Lisp image. So I'm just showing you what it's doing here. It's wrapping everything behind a eval line. This is particularly useful, especially if you're, switching between different versions of the same package that in your running Lisp image. So, some specific features on this that I want to show you is, which I thought were pretty cool, was the fact that you could, in addition to the following keywords, which I just showed you, use export. You can also include some of the standard def package things, shadowing, import from, and so forth. Now, I don't have an example of this for our current package right now. But if you wanted to recycle the package's exported symbols from another package, so if you're using another package in your current package, and you wanted to use some of those exported symbols, you could use the recycle keyword, which internally would do some additional macro magic to actually ensure that it properly gets rehomed to the current package that you're defining. And what that means is the symbol itself, when you do a package lookup, is not defined in the package that you're using, but the package that you're defining. I'm trying to. I think for next time, I'll give you more of a concrete example of this, because I know that itself is a lot to swallow. But it's more about where something is being defined, so that you can actually use that API call when you're defining a particular package. That's where this particular keyword becomes useful. There are other things that are here that in define package that I'll let you guys play around with yourselves, just because I can't right now think for my use cases of a case that I would use these. And this is things like mix, which takes a bunch of different packages, but uses shadow importing from to resolve conflicts for names. And it does automatic name resolution, so that you get a set of names that aren't conflicting with each other across all the packages. It has also re-export, unintern, and local nicknames too, which local nicknames is a convenient way of checking to see if the underlying Lisp implementation has support for package local nicknames. A feature that's available at the very least on SBCL, but I think it's being adopted in other places. You can certainly use local nicknames to do that check for you, and if it's available, you'll get the local nickname for your package. If not, it will use the full package name when you actually try to use it in your application. So let's move on to the third one that I want to actually talk about today. Before I do, are there questions from our YouTube audience, or questions from okay. The third package that I wanted to go through as part of UIOP is UIOP/Utility. This is a package that and this is again a running theme in today's episode. It's about portability. It's a set of APIs that will give you some portable functionality across different Lisp implementations to deal with string manipulation, as well as classes, comparisons, conditions, stamps, and so forth. It also has a nice little utility that I'll be honest, I started playing around with last night, but I'm still not entirely sure that I can really properly explain it. But I'll just mention it here. It's a utility that allows you to define functions for debugging specifically. These are a bunch of helpers that you could wrap around using these macros and functions, and the underlying debugger registers them, and then you can actually use them for debugging. In particular, there is something called in this package UIOP debug. And if you look at this, you could specify a set of keys, and those keys are things that are getting. My understanding is they get registered somehow by the Lisp debugger, and that they can then be used when you are compiling or running your Lisp application. And again, I just started playing around with this particular utility, so I'm gonna hold off on actually mentioning how one would use this until next time, just because this will help improve your debugging experience apparently. But I have to go and play around with it to actually give you whether or not this is actually really useful or not. But let's go through some of the other functions that this package provides. One which I thought was pretty neat was a macro called with upgradeability. Okay. With upgradeability gives you a way of defining or undefining functions, so that you could, when you define a new version of these guys, you can, this macro makes sure that if this is being loaded into a running Lisp image, and those symbols exist, it will undefine them cleanly and redefine them, so you don't get any necessarily warnings. At least that's how I understood what this function does. This macro does. So let's kind of define it. If we look at the macro expansion of this, you'll see that, let me just clean this guy up. You'll see that what this does is it uses the underlying defund star, which is another utility function that we didn't cover, but it is there for lower level macros. I recommend you not using that. Just use the standard CLDefun and let with upgradeability do the macro expansion the way it expects it to. It will then take that and make sure that the app, if we redefine print home directory, or we load this library in another running Lisp image that has a print home directory in the same package, it will undefine it correctly and redefine it correctly. If we look at this specifically, you can see some of this here on how some of this magic works. And here you can see that this is just a function call that goes down to. But one recommendation I have is when you are defining your functions or your APIs, and you are using UIOP and trying to make it portable across different Lisp implementation, is to wrap your functions that you know that you're going to change between different things with upgradeability, so that they are loaded into Lisp images in a clean fashion. This is particularly useful for other cases too as well. Additionally, and this is something that I did not realize, because I know Alexandria has it, but according to the documentation, it's something that they've been trying to move some into ASDF itself. There's a couple of pieces of or subsets of functionality, common functionality from Alexandria and Fair Utils that have been added into UIOP and that are part of this utility library. And that's things that are handled for flow control. So if you are importing, for example, Alexandria for the following APIs, you don't necessarily need to do that anymore, just because it's available for you with UIOP. So one example is iflet. Iflet is available in Alexandria, but if you needed iflet, you don't necessarily need to use Alexandria to actually to define it. You could just use UIOP :iflet. So for folks who haven't seen iflet, iflet is basically the same as if you do, you know, we've just had a review. Let's say that we have some number that we read in from some file, okay, and we're just doing a let here. X7. We are just going to go ahead and say print. Some says greater than 7. So, sorry, 6 is less than 7. Which you can see here. This, if you're trying to do in using iflet, you would use UIOP iflet bindings, and then say let's pull up one thing. Actually, a better example is, let's say that we are doing some filter across a list to get the even numbers. Which, let's say loop for I from 0 to 10 when even. Let me just print X here. To do the same thing here, you could do the same here with X, and what was it? You could grab the same guy here. There we go. In this, if I remember correctly, yeah, this should do the same thing. You'll get the same thing. So you'll, instead of having, you know, now here obviously I'm not using the iflet the way like with the else condition, but you can totally see this example also using using else. But you can see this code and this code are almost identical. The only difference is the one thing that I'm missing here is just to give you what the complete expansion in this case is. If x, it's kind of the same thing here, and you can see that they're pretty much the same. Okay. All right. So we have if left defined in UIOP now. We have what's it? We have parse body. We have while collecting. We have a couple of additional things for lexicographic comparisons. They have lexicographic less than or equal to. Additionally, there are functions that will test prefix and suffix comparisons to as well inside UIOP / utility that are useful for string comparisons. So you don't have to do additional work between these things. And finally, there's stuff for hash lookups, checking to see if you have particular functions and accesses on how to call them and register those functions. There's one particular name in this thing that I have that I thought was pretty interesting that I did not get a chance to play around with, but I'm going to try and see if I could get it in for next time, which is register hook function, because this is something that's interesting. According to what the documentation says about this guy, and I'll just show it to you guys here. UIOP register hook function. It checks to see if the function exists and that on a particular variable, and checks to see when a particular function is callable, and if it is, it'll call it immediately. So it looks like you could use that to like register like callbacks, but I'm still like trying to understand when this particular function is useful or not. So, but I thought I'd mention it here so that for folks who are playing around with UIOP after we're done with today's episode, if you guys are if you guys find a use case, please post it in the comments and YouTube, so that way other folks can actually see when that particular function is useful. And okay. The final one that I wanted to touch base on today is really streams. Like I said, there's quite a few different major libraries in here, and this might take some time for us to actually go through all of the different functionality that's available in this awesome extension to ASDF. But I think this it will give you enough of an overview for some of the common functionality that you might be looking for. That you, instead of trying to find an external third-party library to run your code, just use UIOP for it, and I think you'd be better off. Just because you're almost guaranteed now that you're casting your application's usefulness or your library's usefulness across multiple Lisp implementations, because it gives you these functionalities. And the package that I'm going to be talking about is Stream. This is an API that provides a portable API for interacting with stream objects inside Common Lisp. And by stream objects, I'm looking at character streams, binary streams, and so forth. These are there's some common day-to-day things that most people end up trying to find a third-party library for that I think this API provides. One of the things that it provides is most people coming from external languages don't realize that standard input, standard output are fully named inside and accessible inside the individual Lisp implementations. Some Lisp implementations, I think the standard actually names it this way. I don't think that different Lisp implementations change the names for standard in, standard out. But what about standard error? Well, standard error, as you can see, does not actually exist inside SBCL. It will, I think, dump out any error code directly into the debugger if it's a condition. But sometimes you want to go and dump that out to a different stream than your than standard output. This is particularly common for, again, shell scripts and Unix utilities, because in Unix you have 3 different streams. You have standard input, standard output, and standard error. To accommodate for this, now there is in UIOP standard in, standard out, and standard error. This is kind of unifying multiple lists that may have standard error already available and already defined with those that do not define it. And that's pretty useful for folks when you're writing, again, portable code. So if you see what standard error is currently defined as inside UIOP, you'll see that SBSys actually defines it as such, which is a file script. It's a file stream for standard error specifically as part of the SBSys namespace. So, and although there isn't a standard error like standard input and standard output, SBCL defines it inside their SBSys namespace. CCL defines standard error in some other namespace for CCL. And instead of using those, you could just use UIOP's utilities to actually unify those 3. You could also set up, and this is particularly useful for folks who want to define redirects instead of using standard input, standard output, and standard error through the external shell environment. If you want to, and this is a pretty common thing to do when you're trying to write transcripts for, like, let's say, tracing applications, or you're trying to dump something out to a file, you would normally redirect your standard input and output to particular files to read in or write from respectively. You could do the same thing by using setups, std in, std out, and std error. Additionally, there is a way for you to actually set up temporary directories, create temporary files using this API. If I remember correctly, where is it? With temporary files, the one that we need to look at. So if we go here, we do UIOP temporary file, and we do stream, and let's say we provide the path /temp/ lisp.txt. And you can see with temporary file is using the same API as with open file. You could the difference is that actually, let me try something out here. Oh, apologies. This is it's not a type symbol. Wait a second. Did I mess that up? Yeah, I did. Second. Temporary please. Should generate this guy automatically for me if I remember correctly. Oops. Ah, right. Okay. So you can only define let's see, /temp. Let's do this directory /temp. Right. And obviously with the direction we need to specify, much like with open file, we need to also specify is there a default actually? Let me see what something here is. Which is not of type symbol. So what we do here is, right. So if we look at with temporary files API here and their function signature, it takes in a stream object, a path name, directory. You can add prefixes or suffixes starting with it. So when it creates a temporary file, you'll know it if you need it. So or a file extension. You could also specify whether or not the temporary file should be kept, so that you could later, log it or not. Just like this is similar to mktemp if you're familiar with the C call. Mktemp does something different, something similar. And there's some additional things for whether or not it's readable or writable, the element type and so forth. You can actually use this to actually go and write to and from a stream. So if you wanted to say keep true, let's say prefix is CLSG and suffix is txt. Say we do this, and say format hello. This is pretty much the same approach that you would normally use if you're, trying to generate some sort of file. If we go into here now, into our shell, which let's see, shell. Okay. And we go to /temp. We should see CLSG/temp. So if we go and actually look at CLSG/temp, you can see that it'll write stuff to a file. I've used the path name one is a little bit odd. I thought the path name one, I got the syntax correct because I'm used to using this just to write out streams to a temporary file. This one I've never actually used the path name one. That was kind of like new to me when I was looking at the documentation. But that is something of a useful thing to have. Now again, I know it's where I'm running a little over here, but there are plenty of other APIs in this particular package that I think. Sorry, not APIs, functions and macros inside this particular package as part of the underlying API that's provided. That will let you deal with finishing outputs, reading streams, copying streams from one stream to another stream, which is pretty useful. Slurping streams has strings. And there is even some syntax and function calls for string reading. So, dealing with things like new lines, you might have, for example, for particular file formats, carriage returns following by line feeds, as well as new lines that you may want to eat up when you're reading it into from Common Lisp. It's using this with something that another API that it uses called with safe IO syntax, which I have zero experience on using, but I'm just mentioning here that it provides essentially some machinery for you to like deal with conditions and things like that. So with safe IO syntax. If you provide the particular package that you're dealing with, it'll actually go in and sorry, let's say that. Okay, let's see what this is. What? Oh, sorry. I have to use a keyword argument if I remember correctly here. Yeah, package. Okay. And you'll see that it essentially creates a closure once it finds the particular package, and it'll allow you to do reading from that package and so forth. I think I'm going to go ahead and end it here just because. Like I said, there is a couple of these that I'm not entirely certain about. I will say that for folks who are used to using closures, print line, there is a print line in UIOP. So for folks who don't want to use, format and don't want to have like what hello does, which is if you're using hello in print in the REPL, you will use it will print out the hello and then gives you the return value of the last expression. And if you use format, you will notice that it won't do that. It'll return nil. What UIOP print line does is it uses prink to actually go in and print the object, and then does a terminate print. So for folks as a review, if you've never used either print line, this print line is equivalent to a function like if you said print that takes in some string, and what it'll do is it'll print it and then call Terry Pre, which for folks who aren't familiar with the CL nomenclature, Terpre actually is short for terminate printer. So that's how you actually print out a new line directly inside Common Lisp. So these two would be equivalent. Print line. Sorry. That's that, and that's that. So there you go. There is also a write line for folks who want to have a write line, and it'll also do terminate print on the stream as well afterwards. I have to come up with one example for that. I just don't believe I can just use it. I think that's on the stream. So if I do UIOP write line, I don't think I could just use it. Let's see. Okay, looks like I can do so. Let me see this. This is equivalent to essentially doing the same thing on the following. Write stir. The default on the stream is going to be standard out if you guys use the write. And then terminate print standard output. Where is it? Out. This is essentially the same function. Let's call it a number of keyword arguments. Hold on a second, right? Right, stream. That's what I meant. Got it. So this guy is the same as this guy. Let's see here. Let's see there. All right. So there are other things related to thunks and things like that that I think that we'll touch base next time before we start talking about two other library sub-packages in here, which is dealing with path names as well as images, and then we could start talking about some of the more interesting aspects like running external processes through UIOP. As well as dealing with compilation results using UIOP as well for when you guys are managing packages in a portable manner and getting your applications or libraries set up for distribution. So that's it for me. Apologies for going slightly over. I will see you guys next week, and I'll talk to you guys soon.